Hello everybody, good afternoon. I am Reeti Mukherjee. I am here with yet another live session on the subject Kinematics of Machinery. So I hope these live sessions are helping you. I hope this session again helps you in further chapters, learning further chapters. So here, in the previous sessions, we have learned about totally introduction about the links, mechanisms, machines, and then how they are moving, the motions that they are going through, the velocity, the acceleration. Then we have learned what kind of pairs that they are making. Let us say the lower pairs, higher pairs, and different kind of pairs. Then the last session, we have learned about one such example saying cams and followers. We have seen how different types of cams are there and different types of followers are there. We have also learned about the motion of the followers and analyzed them deeply. In this session, we will learn about yet another example of a higher pair saying gears and gear trains. So let us see how this goes. In this chapter, we will be learning about gears and gear trains. The name is very familiar, but not many of you know about what exactly gears are and what exactly are gear trains, and how this came into existence, what was previously used, which was the technology that was previously used, and how this gear has advanced now. So previously, the history says that they used to use friction wheels, which had a circular disc kind of projections like this. So they had only sufficient amount of projections on the periphery so that there was a slip condition that existed in this. Okay, so to have a better advancement, we say, see, I'll give you a clearer look on this. See, this is a disc which is following the motion of this one, and there is a very small smoothness is there. Not exactly smooth, I will not say that is smooth, that is having sufficient amount of projections on the periphery, but they are not getting engaged with each other. You can see that is the fault with this friction wheels. So further, they have given this kind of structure which had projections on the periphery, and they were very well engaging with each other, and the slip condition was removed out of this. So that is how the gears exactly has come into picture. Here you can see that the motion of one particular shaft is getting transmitted to the other shaft, but the case is that the distance between the two shafts should be smaller. So in case the distance between the two shafts are very, very small, the gears are used to transmit the motion between two shafts. And here how they are benefit over ropes and chains, because these have positive drives instead of negative drives found in belts, ropes and chains. So here we have, previously we had friction tools which looked like this, friction wheels, and over that came the gears. So how about gears? How do you write the, let us write the velocity ratio. I'll say that the velocity when on one shaft is transmitted to the velocity of the other shaft. So it should be equal to each other. So I'll say V1 is equal to V2, right? So how to get the relation between the rotations, because the gears are rotating, they are not having any linear velocity. So how we will transmit this particular expression into the terms of rotations and diameters and etc. So let us say V1 is equal to V2 initially, but we know that linear velocity is related in terms of angular velocity when we say V is equal to R omega. So I can say V is equal to R1 omega 1 is equal to R2 omega 2. Again, we have R1 omega is nothing but 2 pi N1 by 60 is equal to R2 into 2 pi N2 by 60. Okay. So if I want to write down, let us say 60 and 60 gets cancelled, 2 pi and 2 pi gets cancelled, we have R1 by R2 is equal to N2 by N1. So here we can get the ratio of the relation between the ratio of that particular gear to the rotations that it is making. Okay. So this is how you derive the relation between the ratio of the radiuses and the rotations that each gear, let's say driving shaft gear and the driven shaft gear is making. So this is how the engaging is happening there. This is nothing but called as teeth both the wheels over here, both the gears over here and here are having teeth which are getting engaged with each other in order to avoid the slip condition. So how are the gears classified? Basically they have 4 basic types of classification. First one is based on the position of the axis of the shafts. Axis in the sense the axis of each shaft is the main selection criteria over here. Next is based on the peripheral velocity. We also have the different kinds of gears based on the velocity that they are going through. We have based on the position of the teeth on the wheel. How are the teeth placed on the periphery of the wheel? We have a classification based on that as well. We also have based on the type of gearing. Which type of gearing is each one making that? On the base of that also classification of gears are happening. So let us see first one based on the position of the axis of the shaft. Based on the position of the axis of the shaft, we have 3 different types. One is the parallel shaft, parallel types of parallel shaft gears. Second one is the intersecting shafts gear, and the third one is non-parallel, non-intersecting types of gears. So let us see how they look like. First one is the parallel shafts. You can see the gears are arranged on a shaft. So through this hole the shaft will be placed and the axis of 2 shafts will be definitely parallel to each other. So one such example is spur gear here. Spur gear comes under the parallel shaft example. You have intersecting shafts. You see the shaft over here is like this and the shaft over here is like this. So they will somewhere go and intersect. This type of gears, again you have an example of bevel gears. Bevel gears are one such example of intersecting shafts. You have non-parallel and non-intersecting. These are neither parallel nor intersecting because they are making certain angle and they are not intersecting. Okay. So this kind of gears are nothing but called as spiral gears or skew gears. Bevel skew gears, that is the example for non-parallel and non-intersecting. So based on the peripheral velocity of the gears, you have low velocity, medium velocity and high velocity. Obviously we have these 3 types of velocities. So for the low velocity, they work under, let us say 2 meters per second only. Up to 2 meters per second you have the gears that is called as low velocity gear. Medium velocity gear works between 3 meters per second to 15 meters per second. And obviously before above 15 meters per second you have high velocity gears. So this is nothing but based on the peripheral velocity of the gears. You have 3 different types: low, medium and high. Let us see. Based on the position of the teeth on the wheel, you have straight types, inclined type and curved type. Let us see the examples. So here you have the teeth arranged on the peripheral. You can see the teeth are all straight in nature. So this comes under the example of straight kind of teeth on the wheel. This is also having the same way. The next one is the inclined shape. Inclined, see you can see on the peripheral of this particular disc, you have the teeth inclined to the axis. Inclined to the axis, so that is nothing but coming under the inclined type of gears. Next comes the curved. See, they are not inclined, they are not straight lines, they are curved. They are curved in manner, see, like this. So they are curved in manner. So that's why this is coming under curved type of teeth on the gear. So again, this is a spur gear. This is again helical gear. This is nothing but again spiral gear or skew gear that we have seen just before the example. Next comes the based on the type of gearing. So what are these types of gearing? External gear. External gear, in the name itself it says that the gearing is happening on the outer periphery of the particular wheel. Next is the internal gear. The wheels that is there, you have the internal projections on the wheel. So that happens where internal gearing is happening. The next one is the rack and pinion. This rack and pinion is very, very important in here. I will show you the examples. See, this is how your external gearing is happening. You have tooth on the outer periphery, it is projected outwards. So that is external gearing. This is how you have internal gearing. You have internal tooth over here. You have all the teeth that is projected inside and a gear which is having external teeth is rotating in between. You also have a rack and a pinion in which the pinion is rotating over here and the rack is the straight infinite radius projection of the tooth. This is how they look like. This is the external gearing, internal gearing and rack and pinion kind of gearing. So now we have known about different types of gearing. So let us see how the different terms that is used in gear topics. So let us say we have selected a certain part of the gear. We have taken two tooth over here, two teeth, and let us see how they are having different names. Let us say first one is the face width. You have the tooth over here, and the width that is making, that is nothing but the length of this to this. The tip to tip is nothing but the face width. I told you this is nothing but a tooth. So single one is called as a tooth. The body over here is called as the face or the flank. You have three different circles: addendum circle, pitch circle, and dedendum circle. So we will learn about the definitions. You just see, observe over here, the pitch circle is passing through the midpoint of addendum and dedendum circle. You also have clearance over here, the distance between these two. So dedendum is nothing but the distance between the dedendum circle to the pitch circle. So this distance, and the distance between the pitch circle to the addendum circle is the addendum there. Addendum is mentioned with the letter A. This is mentioned with the letter A. Okay. So tooth thickness is nothing but this one. You have a normal drawn over here, and the distance between two tips over here is taken as tooth thickness. So this is nothing but different terms that is used. We will see further terms also in the definition part. We have pitch circle diameter. Pitch circle diameter. So pitch circle diameter is nothing but the diameter of a circle by which it is pure rolling action is taking place. Pure rolling is taking place, and it is the pitch circle diameter. Next is the pitch point, point of contact between two pitches of the circles of the mating gears. Next is the circular pitch, which is denoted with the letter PC, with the term PC. So we have the formula PC is equal to pi into d by t. This is important. Why? Because they are asking different type of questions to find out the circular pitch in the different exams that you are attempting. So based on that, I have taken few of the important points only. So this is one of them. Next is the diametral pitch PD, and the relation between that is PD is equal to T by T. So where you see PC and PD, they are related by the term PC into PD is equal to pi. So basically, out of all that, this formula is important. They are asking in many competitive exams also, as well as the end semester exams. So this particular formula is important, please note that. Then you have a module. It is nothing but the length of the pitch circle diameter per tooth. Per tooth, okay. It is denoted by the letter M. This is also important. You have different values for addendum, dedendum as well. We will discuss that in the next slides. The formula for this is M is equal to D by T. So from here you can find the relation between M and PD also. They are reciprocal to each other. You can find out. See, PD is nothing but T by D and M is D by T. So they are reciprocal to each other. You have addendum, as we have discussed just in the diagram of nomenclature. We have addendum, which is denoted by letter A. So distance between nothing but a pitch circle to the addendum circle, we have addendum, which is having a value of 1 module. The value is predefined. You have the addendum value as 1 module. You also have dedendum, which is nothing but the distance between the pitch circle and the dedendum circle as well. That also we have discussed, which is given as the value of 1.17 module. Or we can also find using this particular term 1 plus pi by 20 into the module of that particular gear. So the addendum circle is nothing but the circle that is drawn which passes through the top of the tip, and this is nothing but the bottom of the tip, that is dedendum circle. So addendum is on the top of the tooth. You can draw one circle from the center, as well as the dedendum is nothing but it is passing to the bottom of the tooth. Next is the face of the tooth. We have discussed that in the diagram. We have seen how the face of the tooth is looking like. We also have the flank of the tooth. Then path of contact. Path of contact is nothing but the curve traced by the point of contact of two mating gears. So that is nothing but locus of all the points of such point of contacts. We have path of contact. We also have path of approach, which is nothing but the path of contact from the beginning till the engagement to the point of the two mating teeth. Path of recess, we have seen in the diagram, it is mentioned, path of recess. Then you also have pressure angle. This pressure angle is important in the exams also. In the end semester exams, they give problems based on this pressure angle. They ask you to find out the pressure angle. So they also ask you about the clearance. These two terms are again important. So clearance is given as the formula of this one. The dedendum circle, dedendum value minus the addendum value. That is nothing but the difference between the addendum to the dedendum. You have 1.157 module minus 1 module, that is given you the value of 0.157 module. If the module is given, you can directly find the clearance but by just multiplying you with the value of 0.157. You also have the profile. The curve forming face and flank is known as profile. You also have pinion and rack. We have discussed rack and pinion. So pinion is nothing but the smaller that projected peripheral that wheel, which is known as pinion. The rack is nothing but let's say the diameter of that particular rack is going to be infinite. So that's why it is a straight line actually. The rack is a straight line which is having projection of the tooth. Then you have gear ratio. This gear ratio is very, very important, I'll say, because they ask you about to find out the gear ratio, which is the number of the ratio of the number of teeth on the gear to that of the pinion. Pinion is nothing but what? A smaller gear. So it is known as the gear ratio, which is given as, the formula is given as like this. G is equal to capital T by small t. You have velocity ratio. Velocity ratio is also the angular velocity of the follower to the angular velocity of the driver. This particular formula is also important again. Pressure line. This pressure line is also the common normal at the point of contact of the mating gears, is known as pressure line. This note point is please noted because this is also important. The force is transmitted from the driving tooth to the driven tooth, okay, along this line, pressure line. So next we will learn about the law of gearing. See, we have learnt about what a gear is, how it has come into existence, and different terms that is used in gearings, and different types of gears also, rack and pinion, and then spur gear. I'm talking about so many types of gears, spiral gears and bevel gears and etc. So you must be wondering how only they are able to mate with each other. So of course they are having certain law that they should follow. That particular law is called as a law of gearing, which says that when you are having a mating, let's say contact surface is there. When you have a contact surface as a common contact surface, on that particular point, if you draw a normal, common normal to the two contact surfaces, that particular normal has to divide the two centers, the line joining the two centers, into a particular ratio. That particular ratio should be the inverse of the ratio of the angular velocity. So that is nothing but the statement of the law of gearing. So let us see how they are saying whatever I said, is it valid or not. Let us say, so this is particular point, this is nothing but the particular point of the common point of contact over there. So at this particular point you are drawing a common normal. See, this is the common normal that I have drawn. So this particular line is dividing this line joining the centers of two bodies at a particular ratio. So that ratio is given as omega 1 by omega 2 is equal to BP by AP. This particular ratio is constant. This pitch point has to be constant in order to maintain a particular ratio. Omega 1 by omega 2 is nothing but BP by AP. We also have the velocity of sliding, because see, we have seen that two particular bodies are mating with each other. So there should be some sliding kind of nature that is happening. So how to find out the velocity of sliding? At what velocity are the two tooth, let's say the driving and the driven one, are how they are sliding with each other? We should find out. So that is given as, that particular thing is given as velocity of sliding, which is nothing but omega 1 and omega 2 into PC. PC is nothing but the diagram that is given, PC. You see the distance over here, PC, that will be given. And if you have omega 1 is, again if you are wondering, omega 1 is nothing but the angular velocity of the driving shaft, driving gear, and omega 2 is nothing but the angular velocity of the driven shaft or gear. So if you find out this particular term, that will be the velocity of sliding. Next we have different types of tooth. I am talking about gear is having different number of teeth that is arranged on the peripheral of the particular wheel, right? So how many, what is the behavior, how is the teeth formed, how is the teeth let's say projected. So they follow generally, we have a law of gearing that they should follow. So following all those laws and everything, we have only two basically commonly used profile of the teeth. One is the cycloidal profile, the other one is the involute profile of the teeth. So let us see how this cycloidal profile of teeth looks like. So cycloids and epicycloid, hypocycloid we have seen already. So we are talking about cycloids here. See, this is one of the wheel and this is the other one of the wheel. When they are mating with each other, this is the profile that is generated. So once you see over there, that is nothing but the cycloidal profile that is generated. So you see the tooth 1 is there here, tooth 2 is here. So this is nothing but the profile that is generated. The generating circle is this one. So pitch circle is generated again, you see the common point is here. So tooth 1 and tooth 2 is there. So when you join, when you project different locus points, you can generate this cycloidal profile. Next one we have involute profile. So involute is nothing but when you are unwinding the wire over any object. So same thing we are doing over here for a circle also. So see, this is how they are generated, involute profile. So mn is nothing but the distance. You have the pitch circle of the wheel 2, this is the wheel 1, this is the wheel 2, and common tangent is drawn over here. So this is how your involute type of tooth, involute profile of the tooth looks like. You also have length of the path of contact. So length of the path of contact is path of contact over here to here, E to F here. So that is given by the term over here, length of the path of contact is given as RA square plus RA square minus R square into cos square phi plus small RA. You must be wondering what is this RA. RA is nothing but, see, you have this one, radius of the addendum of the bigger gear, that is nothing but here, see, addendum circle radius RA, and here you have a smaller one, that is pinion. Smaller one is taken as small RA over here. So we have the arrangement like that. So if you apply this formula to find, you can find the length of the path of contact. You also have length of the arc of contact, only the arc. You have this arc contact is from here to here, this particular thing. This particular thing, E to F, you have the path of arc of contact, which is given as length of path of contact divided by cos phi. So cos phi is nothing but the angle over here that you can see, phi over here, the angle that is made. So length of the path of contact by cos phi is given as the length of the arc of contact. So you have number of pairs of number of teeth on the periphery, right? So how to decide that how many teeth should be engaged on the periphery of the wheel? So that is again given like this. So number of pairs of teeth in contact should be taken as length of the arc of contact divided by the circular pitch of that particular gear. So accordingly the number of teeth will vary. We also have predefined some of them. If the phi value is given, you also have some predefined numbers for the number of teeth also, that we'll see. So once you have two tooth that is mating with each other, you also sometimes see the interference of the first tooth to the other tooth. So how is the interference defined? Let's say defined. It is nothing but the interference. How can you say whether the interference is happening or not? So you see, when the interference is happening, the first tooth, the one of the tooth is going to undercut the root of the other tooth. Okay, the tip of one tooth, if it is undercutting the root of the other tooth, then I can say that the interference between two teeth is happening. So here interference is nothing but the phenomena between the two mating teeth when the tip of one tooth is undercutting the root of the other tooth, undercuts. So one tooth is going to undercut the root of the other tooth. Then only you can say that the interference of the involute tooth is happening. So you can see the diagram also, you can relate with that. So what is the number of tooth that is required on the pinion? Previously it was on a wheel. Wheel is nothing but the bigger wheel, right? So bigger gear. Here we have pinion is nothing but the smaller gear. So on the pinion how it is given, we will see. It is given using the formula of 2 into AP. Here AP is nothing but the ratio please mind it, it is nothing but the ratio of the addendum radius in by the module of that particular pinion. So AP is nothing but AP by M actually. Okay, addendum radius of that particular pinion divided by the module. That ratio is nothing but taken as AP. So you can have G is nothing but the gear ratio. We have discussed that previously as well. So as I was telling, there are predefined numbers already. So in case you have the alpha value as 14, 1.5 of composites, you have minimum number of teeth on the pinion should be 12. 14.5 of full depth involute, that is a profile, you have 32 number of the teeth, and so on. If you have 20 degrees, you have 18, and if you have 20 degrees stub involute, then you have 14 number of teeth on the pinion. So the number of teeth required on the wheel to avoid interference is this. So we are going to avoid the interference. Why we are avoiding the interference? Because if the interference is happening, wear and tear of the gear will be in a maximum level, and we have to let's say replace that. There will be some of the damage. So that in order to avoid that, we are going to project that number of tooth like this. T is given as 2 into AW by 1 plus 1 by G into 1 by G plus 2 into sine square phi minus 1. Where G is nothing but again the gear ratio, and AW is nothing but, as I told you, it is a ratio. Again AW is nothing but actually AW by M, where AW is nothing but the addendum radius of the wheel, because we are talking about the wheel over here, so we are taking AW. If we are talking about the pinion, we will take AP. The minimum number of teeth on the pinion now. See, I told you we are talking about the rack and the pinion, so we will talk about here 2 into AR by sine square phi. That is nothing but the minimum number of teeth that is on the pinion to avoid interference, this one. So till now we have been talking about rack and pinion wheels, annular wheels, etc. So here we also have helical type of gear. Helical gear we have just seen in the type of gear where they were inclined, right? Inclined type of gear. One of such example is helical gear. You can see the diagram. You can see that the lines are inclined like this, and they are forming certain angle over here. That is nothing but the alpha or helix angle we say. So this angle is nothing but the helix angle. This is nothing but left-handed helical gear, that is right-handed helical gear, and this is the shaft on which the helical gear are mounted. So common terms that is used, as I told you, the helix angle, phi. Helix angle is the angle here over here, that the teeth is making with the axis over here. You also have normal pitch, which is denoted by Pn. You also have circular pitch, which is given as Pc. The relation between the normal pitch and the circular pitch is given as Pn is equal to Pc into cos phi. Cos phi means phi is again nothing but helix angle in between. So till now there was one half of the session. Next we will discuss about gear trains. This gear trains topic is going to be very, very interesting and very, very important as well. So here till now we have learnt about gears, right? So gears are nothing but you are transmitting the motion from one shaft to the other shaft. So why is the gear train coming to picture? See, train is nothing but, as you visualize a train, you have number of bogies coming together, yes? So here also in gear trains, when they name it, we are saying that number of gears which are mounted on the shafts. So we are able to transmit power from the one shaft to the other shaft using number of gears, not only one single gear but 2 or more number of gears. So where you have 2 or more number of gears which are arranged on a shaft just to transmit the power, we are talking about gear trains. So this is how they look like. See, you have on a 2 shafts, shaft 1 is there, shaft 2 is there. First one is the driver, the second one is the driven or the follower. We are already familiar with such terms. We already know what they are, driver and the driven things. We have learnt about this in Hooke's joint and etc. So this is how when one is rotating over here, see it is automatically, if this is rotating in clockwise, this is going to rotate in anti-clockwise. The rotation of one to each other are going to be always opposite. So types of gear trains, how many types are there? Let us see. One of them is ordinary type of gear train. and the second one is epicyclic gear train. So ordinary gear train is again divided into simple gear train and compound gear train. Compound gear train again divided into reverted and non-reverted type of gear train. We will discuss about each one separately. So ordinary gear train, in that we have simple gear train. Let us talk about that first. Simple gear train is like this. So you have number of gears like this. One is the driver, this is the intermediate gear. So you are transmitting the power from 1 to 2 and then 2 to 3 and finally the power is transmitted to third shaft. Next is the compound gear train. See, you have reverted compound gear train. So you have intermediate shaft, you have this coaxial shaft. The axis of this particular shaft and this shaft is coaxial. Coaxial means the axis of both of the shafts are collinear to each other. See, on the same shaft you have two gears mounted. So this is coming under compound gear train, not the simple gear train. In the simple gear train, one shaft is having one gear. In compound, you have two or more number of gears mounted on the same shaft. So you have epicyclic gear train as well. So epicyclic gear train is looking like this. See what is the difference? You have one arm. You have this new term called arm over here. See, on the first shaft and second shaft, this is the gear that is having, this is the first gear. This is nothing but the front view, this is nothing but the, let's say, side view you have. So here is the one gear, this is the one gear, and over here you also have an arm. Arm is coaxial with two of the gears, you can see. Here also one of this is there, the center is there, the middle one is nothing but called as the arm. So arm can be fixed or the gear can be fixed in the simple type of epicyclic gear train. You have the arm is fixed, and the epicyclic gear train you have one of the gear as fixed. So this is epicyclic gear train is also called as planet and sun type of gears. See, as I was telling, this is simple gear train. The arm is fixed over here. This is the gear 1 and this is gear A and gear B. In the epicyclic gear train, the gear A is made to be fixed over here and the arm is rotating. With the help of arm that is rotating, the gear B is going to rotate over this one. The arm is rotating as it is shown over here. So now let's say velocity ratio of the gear trains. How to find out the velocity ratio? Because in the simple gears, we have simple gear, when we were learning about simple gears, we have talked about how the relation of the rotations N1 and R, how they are related, we have seen. So here we have number of teeth. So how is the relation between the rotation and the number of teeth, we will see over here, which is given by this particular thing called VR, velocity ratio, where the speed of the driver and the speed of the follower are taken in ratio, and that is particularly given as velocity ratio. And when you have the reciprocal of velocity ratio, you get train value. This train value is also asked sometimes. So train value of particular gear, if they are asking, you have to just find the gear ratio and then you have to reciprocate that. Reciprocal of gear train. Velocity ratio is nothing but the train value of the gear train. So let us find out the velocity ratio of different types of gear trains that we have: simple gear train, compound gear train, reverted and epicyclic. So simple gear train looks like this. Here they are inversely proportional. You can see N1 by N2 is given as T2 by T1. So T2 is nothing but the number of teeth on the second gear. T1 is nothing but the number of teeth that is given on the first gear. N1 is nothing but the rotation that the first gear is making. N2 is nothing but the rotation that the second gear is making. So this is nothing but you have the driver and the driven over here. The shafts are given like this, and this is nothing but the gear 1, gear 2. So if this kind of simple gear train is given, the velocity ratio is given like that. N1 by N2 is equal to T2 by T1. Similarly, if you have a compound gear train, you have speed of the first driver, the formula is given like this. Actually, if you further divide it like this, 1 to 2 and 2 to 3 and 3 to 4, you can actually find out using the first formula as well. But finally, when we are finally giving the formula, you find it that the ratio, velocity ratio of the compound gear train is observed to be the ratio between the speed of the first driver to the speed of the last driven, and then that is equal to the product of the number of teeth on the drivers drivens by the product of numbers of the teeth on the drivers, which will be given as, let us say, speed of the first driver is nothing but N1 and speed of the last driven is N4. So N1 by N4 is equal to the product of the number of teeth on drivens. Now, which are the drivens ones? Driven is one is driving the second one. This is the driver, this is the driven. This is driver and this is driven, right? So, if this is driven, again third one is driving the fourth one. So, third is driver again and fourth one is driven. So, we can have, now we can easily write the equation that N1 by N4 will be equal to, see, number of teeth on the drivens. How many are driven? 2 is driven, 4 is driven. So, I can write that T. So, this is nothing but product of the number of teeth of number of drivens T2 into T4 divided by number of drivers. How many are driver? 1 and 3 is the driver. So, I will say T1 into T3. So, this is the final equation for velocity ratio of the compound gear train that you have when you have such arrangement. For example, I have already given 30, the number of teeth on the driver is 30 over here, then driven is 75, for the driver over here is 20, and the fourth gear is having 50 number of teeth. So, kindly find that, and let us say if I put the value over here, let us find out the ratio. If I put the value over here, let us say I will find the N1 by N4 ratio. So, T2 is how much? T2 is 75. 75 into T4. T4 is 50 over here. This is just for an example. T1 is again 30 and T3 is 20. So, let us say 30 into 20. So, this particular ratio if you find out, you can also find the ratio of the speeds of N1 by N4. Okay? So, that is how they are related. So, you have velocity ratio of epicyclic gear train. So, this ratio, velocity ratio of epicyclic gear train is very important. In this whole chapter, this is one of the very much let us say scoring. Actually, they ask questions based on this topic very frequently. So, this is nothing but there are basically two methods for solving the velocity ratio of the epicyclic gear train. The first one being the algebraic method, the second one being the tabular method. So, in the algebraic method, we will see each one anyway. In the algebraic method, we are forming the equations and relative speeds are found out, and finally we are substituting the given values and finding out the ratios. In tabular method, we have a particular let us say performer given for the table format, and we are following just those table the steps of let us say calculation. So, this is how your algebraic methods are given. See, these equations are formed. These equations are formed, relative speeds are given. Wheel A with respect to C, arm C. There is this arm I told you. In epicyclic gear train, there are two gears with one arm. So, particularly this arm is C over here. Let us say gear A is there, gear B is there, and the arm is there. So, relative to each other, we have the speed of the wheel A with relative to C. We have NA minus NC, and subsequently here speed of the wheel B relative to arm C is given as NB minus NC. And finally, we have the equation formed like this: NB minus NC by NA minus NC is equal to minus of TA by TB. So, here minus is giving you that the rotation is happening in clockwise direction. Here we are taking clockwise rotation as negative and counterclockwise rotation as positive. Okay? So, always be specific with those directions. The rotation is happening opposite to each other. If this is rotating clockwise, this will rotate anti-clockwise. So, that kind of relation should be maintained, and we always take the let us say clockwise rotation as negative and counterclockwise taken here as positive here. So, let us say this is algebraic method. Even each one, any value if it is given, you can find the number of teeth of A and B as well. So this is how your tabular method looks like. So tabular method, you have, these are the fixed performer actually. You have to just note it down the same, let's say the format. Arm is fixed over here and they are going through one revolution, then X revolution, then adding Y revolution to each element, then finally finding out the resultant of all of them. So basically if you have steps of motion, this is the first step of motion. The arm is fixed, that is the first step of motion, and wheel A is only rotating one revolution. Okay. So if you have arm C which is stationary, so it is 0, wheel A is rotating one revolution, so +1, and accordingly if you write down the equation for wheel B, that is nothing but given as rotation of NA by NB by N1, NA is given as minus of TA by TB, forming the same equation, same here. So if second step of motion is given as arm is fixed again and they are rotating through X revolution. So if X revolution is given, one revolution changes to X revolution and same is multiplied over here. So minus X into TA by TB. Similarly, you also have to add the second row and third row. So here 0 plus Y here, 0 plus Y is Y here, X plus Y is here, and then this term and this term is added over here and finally giving the resultant over here. Okay. So this is resultant value and we are going to apply this particular formulas only in the, let's say when you are solving the problems. We will see one of the problem also. See, the problem says the arm of the epicyclic gear train rotates at 100 RPM in counterclockwise direction. The arm carries two wheels A and B, okay, with having number of teeth as 36, number of teeth as 36 and 45 here. The wheel A is fixed, first condition is taken as the wheel A is fixed and the arm rotates about the center of the wheel A. Find the speed of the wheel B. What will be the speed of B if the wheel A is instead being fixed, makes 200 RPM clockwise. The direction C, you can see here the direction is given as clockwise. Solve by both the methods, that is algebraic method and tabular method. So we will solve by both the methods. See, these are the given conditions given. Arm speed is given 100 RPM counterclockwise. So counterclockwise is mentioned. So counterclockwise is taken as positive as I mentioned earlier. Counterclockwise is taken as positive whereas the clockwise rotation is taken as negative. Number of teeth on respectively on teeth A is 36, teeth B is 45. So 36 and 45 is taken. What we have to find is wheel A, when the wheel A is fixed, find the rotation on wheel B, and when wheel A is making 200 RPM of rotations clockwise, find the rotation of NB. This is what we have to find using both the methods, algebraic method as well as the tabular methods. Let's see how they are going. Using algebraic method, see I told you have to write the relative equations. NA minus NC and speed of the relative speed of wheel B related to arm C is given as NB minus NC. Okay. So this is how they are meshing. Wheel A is having 36 number of teeth, wheel B is having 45 number of teeth, and this is nothing but the arm C, right. Since A and B are meshing directly, they will revolve in opposite direction, right. This point is also discussed earlier. So let us say speed of the B relative to arm C by speed of the A relative to arm C is given as minus of TA by TB. So you have NB minus NC by NA minus NC is equal to minus TA by TB, which is taken as, let us say, equation number 1. But here you have speed of wheel B when the A is fixed. So A is fixed means you have NA is equal to 0, there is no rotation, right. So if A is fixed, you are not undergoing any kind of rotation. So I can take that NA is equal to 0, but the speed of the arm is there, NC is equal to 100 RPM. Why it is taking positive? Because the arm is rotating clockwise. So clockwise is taken as, counterclockwise. So counterclockwise is taken as 100 RPM plus. So substituting all this value in this particular first equation, if I write down this one and solve, finally we get NB is equal to 180 RPM counterclockwise. Why am I writing this counterclockwise is we are getting the value over here as positive. If you solve this particular equation, you will get this 180 positively. So if you have positive value obtained, you will write that the direction it is rotating is counterclockwise. If you get it in negative, you will definitely have it in clockwise direction. Next, we will also find the speed of the wheel B when A is making 200 RPM rotation clockwise. So here clockwise is taken, so here we will take instead of 0, NA is equal to minus 200 RPM. You also have NC is equal to plus 100 RPM. So substituting the same values in the previous equation, we have the value obtained as 340 RPM, again positive, so it is counterclockwise. Now comes the tricky part, we have using tabular method. So in tabular column method, see I told you, this is the particular predefined tabular format. You have to follow the same format all the time. See, this is nothing, these sentences or these steps are the same as given in the actually format. Arm is fixed, rotating wheel A through +1 revolution, which is given as clockwise, counterclockwise. So here -1. See, only the difference that it is going to make is with revolutions here. If it is counterclockwise, taken as negative here. If it is arm is fixed, rotate to the +x, so +x, add y revolution, y, resultant of the motion is taken as second row and third row, addition of 2 plus 3. 2 plus 3, if you do 0 plus y is obtained as y, x plus y is given as x plus y, and this term plus this term is given as minus x into Ta by Tb plus y. So substituting all these values, we will see how this is going. Speed of C, it will be clear. Speed of the arm A is again given as 100 RPM counterclockwise. So, but in the table, the resultant motion of the arm is given as y. So, y will be equal to 100 RPM here. We are not talking about NA, NB here. We are talking about x and y here because we have predefined and given the variables. So, as wheel A is fixed, NA is 0, we have seen just before. But from the table, the resultant motion of the wheel A is given as x plus y. See, wheel A, the resultant motion is given as x plus y. So, x plus y will be equal to 0 now, right? But x is here from this equation, x is equal to minus y means this 100 will come here. So, x is equal to minus 100 RPM now. Now, from the table, the resultant of wheel B is given as this term. The resultant of wheel B. These are nothing but that is what we have to find actually. So, wheel B is given as minus x into Ta by Tb plus y. So, minus x into Ta by Tb plus y. So, substituting all these value, you get the value as 180 RPM, which is same as the value that we have obtained previously. Here also we are getting positive value. So, what will be the direction over here? Counterclockwise. Next, we have to find the speed of the wheel B when A is making 200 RPM clockwise. So, 200 clockwise is nothing but again taken as negative over here. But from the table, the resultant motion of wheel A is taken as x plus y. So, x plus y will be given as minus 200, and subsequently again same way y is taken as 100 here. Substituting the values, you will get the value as 300. So, again speed of the wheel B resultant is taken as minus x into Ta by Tb plus y. So, speed of the wheel B is minus x into Ta by Tb plus y. Substituting the values, you get 300 RPM counterclockwise, because here also we got it as positive. So, by even if you apply both the methods, you get the values same. You can check previous by solving algebraic method also you got the same value as 180 and 340. Even after applying the tabular method, you also got the same value as 180 and 340 counterclockwise. So, here I will say that this particular method of tabular method is very, very important. You can take different conditions where the A is fixed or arm is fixed or wheel B is fixed, anything, and accordingly you have to follow the same tabular method like this. You have to first write down the tabular column and accordingly you can act, because all the values you have will be given, and accordingly you have to find the resultant of all wheel A, wheel B by using those formulas. Okay. So, this is how we end the session. Let us first, let's say, go through the summary of this total session. In the session we have learnt about what is a gear, how many types of gears are there, what is interference, what is the velocity of sliding. Before that we have learnt law of gearing, because number of gears they are following certain law. Only following those laws we are again having number of profiles of the teeth, let's say cycloidal profile of the teeth, involute profile of the teeth, how they are forming, how the interference is happening, how the undercutting of the tip of the tooth to the root of the tooth is happening. Then we have also seen the helical gear, what is a helix angle, etc. We have also seen the types of gears, because we see in the day-to-day life, we should be able to identify which gear is what and where they can be used, the applications of them. Then we have also come to the second part of the session. We have talked about the gear trains, where we are talking about simple gear train, compound gear train, the velocity ratio, the number of tooth, what is the relation between two of them. Then we have also seen the epicyclic gear train, which is also called as sun and planet type of gear train, which is very, very important in the whole session, I would say. That the velocity ratios are found out for the wheel, for the arm, for the pinion of them using that tabular format that we have discussed. That is very, very important. I am repeatedly saying that that is very important. Just have the same format for the problem solving, and you can find the resultant very, very easily. It is very, very easy. The topic is very, very easy. So with this, I complete the live sessions of the total subject. You have seen the introduction part till the application part. I hope all of these sessions have helped you a lot. Let's say hope to see you with the further videos. Thank you so much.